Hello and welcome to our tutorial on speed time graphs. A speed time graph visually shows how the speed of an object changes over time. In speed time graphs, on the vertical axis we have speed or velocity, and then on the horizontal axis we have time. Usually in speed time graph, you will come across slopes. In this particular instance, we have two slopes. We have a positive slope and then a negative slope. The positive slope denotes the acceleration of the object, and then the negative slope denotes the deceleration. And then in this particular instance, we have a horizontal line up here. This horizontal line denotes uniform speed. To find the total area of an object using speed time graphs, all you have to do is to find the total area under the graph. And then to find the acceleration, just find the gradient. So let's look at this example. It says on the graphs in this exercise, the vertical axis represents the speed, v in meters per second, and the horizontal axis represents time, t seconds. Then we have to find the acceleration between 0 and 10 seconds. So let's go back to the graph to find the acceleration between 0 and 10 seconds. Acceleration is the gradient, and gradient generally is change in y over change in x. In this particular instance, on the y-axis we have v, so this will be change in v, and then on the horizontal axis we have t over change in t. So to find the acceleration, our change in v, that's the distance from here all the way to this point, is 15. So we'll have 15, and then our change in t, the distance from 0 all the way to 10, that gives us 10. So this gives us 1.5 meters per second squared. The unit for acceleration is meters per second squared in this instance. When we go to B says we should find the total distance traveled. Like I said earlier, the total distance traveled is the area under the graph. If you observe carefully, in this particular instance, we have a trapezium. So it's much easier to calculate the area. In the case whereby the shape is not, let's say, definite, you would have to divide the graph into sections and then find the individual areas and then put them together. So let's focus on our example. Area of a trapezium. So in this case, total distance. Area of a trapezium is given by 1 over 2 times sum of parallel sides times height. So this will be 1 over 2. Our parallel sides here, we have the distance from here all the way to this point, which is 60. And then up here we have the distance from here all the way to this point, which will be 40 minus 10. That gives us 30. Times the height. The height is the distance from this point all the way to this point, which is 15. Everything put together gives us 675 meters. Moving on to C. C, we are to find the average speed for the whole journey. And average speed is the total distance divided by the total time taken. In this case, the total distance here is 675 and the time taken is 1 minute. That is from here all the way to this point. That's 60 seconds. And this gives us 11 whole number 1/4 meters per second. I hope you enjoyed the video. Don't forget to subscribe.